All right, this is part two on our turning lecture here. So let's kind of go through some of this. In part two here, we're going to talk a little bit more about work holding methods that are used and reasons for picking one over another. Usually those include run out and weight, or size of the workpiece. We're going to talk more about some of the types of turning tools and how and why we select different types of cutting tools there as well, and mention some safety in regard to the speeds and feeds, your actions, what you're doing, and of course a chuck wrench and leaving a chuck wrench in the chuck. So we'll also talk more about setting up the actual lathe and operating that as well. All right, so in terms of our work holding methods, we have several choices on the lathe. We have chucks. They can be a 3-jaw chuck, a 4-jaw chuck. Sometimes they are 6 jaws as well. We have what we refer to as collet chucks. We can hold between centers. We can use a faceplate. There are mandrels and there are fixtures. Now, in the lab, when I get back in, I will show you we do have both 3 and 4-jaw chucks. We've got a couple of collet chucks, I believe. I'll talk about what a center is, both a live center and a dead center. And then I will also show you some of our fixtures that we will be using here as well. All right, so when we are choosing work holding, we do have 5 selection factors. So we consider the type of work that we're working on. Are we going to be removing a lot of material, or is it just kind of light moving material removal? Are we using rough bar or finished part? So what are the tolerances? We're going to talk about the grip that needs to be held, and we're also going to be talking about turnaround time here as far as our selection. So, because some of these types of work holding devices are a little faster in use than others. So, number 4, we'll be talking about run out, or part wobble, and then of course some special holding abilities there as well that we might need to be using in consideration there too. So those are 5 areas that we're going to take a look at when we're looking at work holding selection factors. All right, so our chucks are both universal and independent. So on your 3-jaw chucks, those jaws move at the same time, so it's a fairly quick turnaround. If we are working with a 4-jaw chuck, each of those jaws moves independently, and it takes a little bit more time to get those set up and positioned with our workpiece to make sure that we are turning it. Of course, if we need to turn eccentric parts, we have no choice but to go into the 4-jaw chuck, so where we can kind of turn one feature on the part and then move that off center and turn an eccentric feature on a part that would require 4-jaw chucks. 3-jaw chucks are pretty quick and easy, where they all move together at the same time, clamp down on the OD of a bar, and we can go right to turning. So they're usually the jaw of choice when we're talking about turning on a lathe. So we can also custom bore soft jaws. That's done for any type of odd shapes that we might need. Oftentimes, if you're doing a first side, second side, sometimes soft jaws will be bored on the second side just to make sure that your concentricity and your run out is held close. So make sure that you don't have to worry as much about that, especially if you're doing large quantity runs. So we also have what we call spring collets, or spring chucks. These are pretty similar to the collet chucks that are back there on the Bridgeport. So they are size to size. We can get them in round shapes. We can get them in hex shape, square shape. We can get special shapes, and we can use these spring collets to clamp down on that. It's also a very highly effective work holding device for turning on a lathe. And we have what we call turning between centers. Now, this is not a very strong setup. It's usually done where we have long shafts or work pieces that we need to kind of turn down. You'd usually have a dead center at the front with what's called a drive plate and a drive dog that's kind of attached to the workpiece, so that the workpiece will be turning in conjunction with the actual faceplate as well. And then we have what's called a live center back on the tailstock as well. So they are very common on manual machines and CNC machines as well, especially if you're doing long shaft work. We have what we call a mandrel. So sometimes we can turn mandrel where parts can be moved over it. We will use something similar to this when we are basically doing the knurl. So just to accommodate and make things a little bit easier on that part, we will use a mandrel fixture in order to knurl the part as well. So these are special types of applications here as well. Faceplate work generally requires bolts and clamps to odd shape. This is probably one of the most dangerous of all of the work holding methods that is done. So, and it should be done by somebody who is more experienced and has a lot more familiarity and practice on these lathes to make sure that everything is balanced. So in the terms of the faceplate and the clamps, obviously, if we are using face clamps and bolts, if we're not balanced, we're going to potentially cause some centripetal forces on there that will also cause some problems in the machining too. So we need to make sure that that is done competently by an experienced machinist. So if we are talking about mounting spindles accessories, so there is a correct way to mount a chuck, collet, and other holding tasks. So obviously we have to have everything clean, because one tiny chip will basically leave everything destroyed and leave marks, and those then would be pretty expensive to have to repair on our machinery and equipment. So when we're going to get more involved in the turning tool in the actual cutting and work holding class, same thing with those work holding devices. So I just wanted to kind of bring this attention to you. So we do need to be aware of what we call the rake angle, a clearance angle, a lead angle, and a nose radius or corner radius on a cutting tool for the lathe. So and here's some of the reasons for it, depending on whether we're using high-speed steel bit or carbide, and the material that we're cutting will also make a big difference. So if we need to take a heavier cut, so we're going to need a larger bit. For smaller cuts, we'll be able to use smaller bits. So, and of course, whether we're machining something like aluminum or brass or steel, a positive and negative rake on that will be important too. So this will get into our tool holding method for the actual cutting tools as well, and we need to be aware of this on the lathe. So we have what we call tool posts, we have some quick change tooling, we have indexing tooling, rockers. There are advantages and disadvantages to each of these. Sometimes it becomes preference for the actual machinist to be using it. Sometimes on your CNC machines and lathes, you're locked into it based on what the machine tool manufacturer has supplied on the actual turret there to hold the tools as well. So we'll go through some of those. So here's some examples of your quick change tool post on manual lathes. Notice the similarities to this as opposed to what we have. And then of course this is an example of the CNC tool turret as well. We're going to be using some of the same type of tooling, but it's going to be mounted into the machine differently. So again, on safety, just to follow up, so we want to make sure that we are always working very safely and very aware of all the potential hazards that could be going on the machine. So make sure that your work holding is tightened well. So make sure that your work support is also tightened and locked in place. Your tool holder a bit, while sometimes you need it to be hanging out, but it needs to be tight and it needs to be hanging out just enough to be able to cut what you need to cut. And then, of course, your speeds and feeds must be acceptable for the operation that you're working on. So, again, lathe safety is managed here with training and just good common sense. So I am here. Make sure that you are asking me questions. If you are in doubt or if you are nervous, stop what you're doing and wait for me to come and help answer your questions and ease your mind, or even demonstrate the proper safe way to use that. So don't become complacent. Don't start to think you're knowing everything you need to know. So it takes quite a bit of practice and machine time to become really fully competent on using a manual lathe. So remember too, the larger the part of the manual lathe, that also increases danger. And of course, the longer, not just in, when I say larger, I'm predominantly talking the diameter of the piece, but the longer the length of the piece is, that also becomes dangerous as well. So, and if it's a long piece, we need to support that piece with the use of a live center there as well. And we'll demonstrate that in the lab so that you understand what's going on there too.